In this presentation, we're going to talk about data wrangling. Data wrangling is the process of taking raw data and convert them to high-quality data for AI and digital twins to use. Let's look at a use case. The use case is we wanted to build a real-time digital twin to monitor the operations on a rig. The data sources can include EDR, control systems, and external sensors. Those data would stream in as fast as every second, and there can be hundreds and hundreds of data tags. So we need to convert that raw data into high quality data. And then we have to take the high quality data, which is time series data, and convert it into SQL transactional data, which is called the events data. The events data are basically what's happening on the rig. How many hours are the pumps operating? Under what kind of conditions? What are the maintenance activities on the rig? And what are the smart alerts generated from all the information available in the data? So how much data are we talking about? Just the EDR data alone, we are talking about processing 500 million real-time data points per day. In addition to that, we actually have to issue 37 million database queries per day. This is because in order to generate all the events data, including the component models, we have to look back in time and correlate a lot of different data streams in order to figure out all those events. So this is quite intensive in terms of both the real-time nature and also the historical nature of data processing. How do we do this? We do this through a distributed graphical approach. There are two components in the solution. One component is the data engine builder and manager. Here, you can imagine you have a canvas in the cloud, and you can drag and drop components to build your data workflow, and you can manage those data workflows in the cloud. But those data workflows don't run in the cloud. You can actually deploy those data workflows to either the edge or other locations in the cloud as containers. Each container would contain this data workflow that can be executed in any location you desire. And this container includes not only the data workflow, but it also includes the database. In other words, every single data engine is paired with a database. This is because for the amount of data that we process, the number of database queries that we issue, a single database runs into bottleneck pretty quickly. So having this distributed data engine, database architecture, but a centralized data workflow management and deployment mechanism, we are able to efficiently build data workflows, but also scale them to as many rigs as required. So this is the result. We show one picture of the final digital twin solution, but we're not going to go into the digital twin solution here. It suffices to say that we have been able to meet the requirement of processing 500 million real-time data points per day and 37 million database queries per day. And these numbers are growing as more rigs are getting this solution. If you have any questions on the graphical distributed data engine, please reach out to us. Thank you.